Hello students, I am Gurmeet Singh. Welcome to CREATA Classes and also welcome to our series on triangles for class 10 student. Note that this complete series is as per the latest updated syllabus, and in this complete series we will cover all these chapters using the power of animation and the visual tool to make the tough concept easier for you. And in this lecture we will cover the introduction to the similarities, and the link to all the lectures is given in the description. Check it out. And students, one important thing, do not forget to download the PDF of the concept and formula list. The link is given in the description. That will be really helpful to solve the question and also brush up the concept whenever you are having the exam or whenever you need so. So without taking any further time, let's start with this lecture. Best of luck. In the class 9th, we have studied about the congruency, the congruent figure. In this chapter, we will cover the similarities or the similar figure. Let's have a glimpse of what the congruency is. Two figures are congruent if they are having the same shape and same size, which basically means that if two figures are exactly matching each other or exactly copy of each other, then we can say they are congruent figure. That is, they are having exactly same shape and same size. And let's see what the similar figure is that we are going to cover in this lecture. Similar figures are the figures which are having the same shape and not necessarily the same size. So similar figure only talk about the same shape, while the congruent figure talk about same shape and same size. So the congruency is having some extra component, that is same size. Note that the difference is generally asked in the examination, the MCQ type of question. The congruency is having same shape and same size, while the similarity is having only the same shape. I will tell you what exactly the same shape means and what exactly is the difference. Understanding the base is very important. Once your base is built, you will be able to solve any of the question related to the same concept. So building the base is very important. Moving further, we are having two figures, two quadrilaterals. These two quadrilaterals are exactly matching each other. If we overlap one quadrilateral over the other, we can exactly match one quadrilateral over the other quadrilateral. It means these two figures are having the same shape and same size. So these two figures are congruent figures. With the same figures, let's understand the similarities. If we take out the right hand side figure and if we try to expand the figure, that is scale in and scale out this figure, we can say now both the figures are having the same shape but not the same size. Are you getting? The shape of both the figures are same, just we have done the scaling. We have just increased the size. So the size is not matching. So these two figures are similar figure. The same shape but not the same size. These two figures are having the same shape. Let's understand this in further detail. Here we are having the two figures. How to check whether both are similar? That is, both are having the same shape. Just take one figure, scale in or scale out and overlap with the another figure. If both are matching by doing the scaling in and scaling out, then we can say both are having the same shape. Here just we have to decrease the size of the right hand figure, and on overlapping with the left hand side figure, both are exactly matching. So we can say both are having the same shape. We can understand this with one more example. We can take these two figures. Here we have to check whether both are having the same shape or not, that is both are similar or not. If we scale in or scale out the right hand side figure, can we exactly overlap with the left hand side figure? No, they are not exactly matching with each other. So we can say both the figures are not having the same shape, that is not similar to each other. Okay? Are you understanding the concept of similarity? Both the figures should have the same shape. It does not matter whether the size is smaller or larger. Unless the shape is same, that is exactly matching only the shape, then we can say both the figures are similar figures. Here let's take the example of a star. We are having a star. Let's copy paste this star. Here these two figures are congruent figure because their shape and size are matching. Let's increase the size of the right hand side figure, the right hand side star. Here now the size of right hand star is larger as compared to the left hand side. It means both are having the same shape but not the same size. Here both the figures are similar figure but not congruent figure. If we slightly twist the left hand side figure, now the shape of both the figures are not matching. Also their size is not matching. So we can say both of these are not similar figures. Not congruent, also not similar. Because their shapes are not matching. Both are stars, okay, but the shape of the left hand side is not matching with the shape of right hand side. I have taken many examples just to give you the idea of what the similarity is. I hope you have got the basic understanding or the basic picture of the similarity. Let's move further. Let's understand the concept of similarity in some standard geometrical figures. First, the circles. Here we are having two circles of exactly same radius, or we can say both of these figures are exactly copy paste of each other. It means both the figures are congruent figures. Got it? Shape of both the figures are equal to each other, that is matching, and their size are also matching. Suppose we increase the radius of right hand side figure. Let's increase the radius. Now can we say both are congruent? No, both are not congruent, but their shape are same. Got it? We have just increased the size. Their shape remain the same. It means both are similar circles. You can take any circles. You can either increase the radius or decrease the radius. All the circles are similar to each other. This is very important. All the circles are similar to each other because the shape of all the circles are same. In the previous example of quadrilateral, we have seen two quadrilateral shape are not matching with each other. But the shape of all the circles are matching with each other. So we can say all the circles are similar to each other. Are you understanding the concept? All the circles are similar because the shapes of all the circles are same. Now a question for you. Can you imagine any other geometrical figure other than the circle in which all the figures are similar to each other? Means all the figure, like we can change the dimension, like in the case of circle we have increased and decreased the radius. Can you imagine any other geometrical figure in which we change any dimension, still the figure shape will not change? You can change any x, y, z, any dimension, still the figure shape will not change. Basically all the figures are similar to each other. Just think, what are the other examples of the geometrical figure other than the circle that comes under this criteria? Pause the video, take some time, take a deep breath, think and come back again. This exercise will be really helpful to you. So welcome back. So the answer is that the geometrical figure in which all the figures are similar to each other are square and equilateral triangle. Let's take the example of square. In the square, whatever the dimension of side you take, all the squares will be similar to each other. Here we are taking two squares. If we scale in the right hand side square, it will exactly match with the left hand side square. So basically any square, here we are having multiple square, we can just scale in or scale out the various square and they will exactly overlap with each other. That is, they are having the same shape, that is similar figure. The next case we have taken out is the equilateral triangle. You can change any dimension of the equilateral triangle. All the equilateral triangle will have the same shape and they will overlap with each other on changing the or scaling in and scaling out. Here we are having two equilateral triangle. Just scale in the right hand side equilateral triangle, it will exactly match with the left hand side equilateral triangle. So we can say both the equilateral triangle or any number of equilateral triangle are basically having the same shape, that is similar figure. So we have seen the three examples. These three examples, circle, square and equilateral triangle, are very important and these are generally asked in the examination. So based on the learning, we can say that, All congruent figures are similar, but the similar figures need not be congruent. This is very important statement. Just pause the video and take some time to analyze this statement. The statement means that if we are taking two congruent figure, these are two congruent figure, then these two congruent figure are also similar. But if we take two similar figures, then they need not be congruent. They can be congruent and they cannot be congruent. They can be congruent if their size are matching, and they cannot be congruent if their size are not matching. Got it? This is very important statement. Note it down. Let's move further to the next concept and let's talk about the polygons, the similarity of polygons. By looking at the figure, we can somewhat tell that is the figure is similar or not. We can scale in and scale out. But mathematically, how to tell both the figures are similar or not? For example, we are having two quadrilateral. How we can tell these two quadrilaterals are similar to each other or not? Here in this graphics or the animation form, we can scale in the right figure and match with the left hand side figure. And we can tell yes, that is exactly matching. So both the figures are similar. But for example, the right hand side figure is slightly twisted, which you are not able to visually identify. But once you do the scaling in and matching it with the left hand side figure, you will be not able to match both the figures. So you can tell both of these figures are not similar to each other. These small differences you will be not able to visually identify it. Like visually you cannot tell whether the two figures are similar or not. So what is the criteria through which you can tell the two figures are similar or not? So in case of polygons, it is having two criteria. The first criteria is that the corresponding angles should be equal. The second criteria is that the corresponding sides are in the same ratio or the same proportion. So we are having two criteria. Let's understand this criteria. The first criteria is that if we are having two polygons, if their corresponding angles are equal. Suppose we are having two polygons A, B, C, D, E and A dash, B dash, C dash, D dash, E dash. The first criteria, their corresponding angles should be equal. Corresponding angles means angle A and angle A dash, angle B and angle B dash. These are the corresponding angle. So these corresponding angles should be equal. Here in both the figures, the corresponding angles are equal. That is, angle A is matching with angle A dash. Similarly, all the five angles, the corresponding angles are matching. The second condition is that their corresponding sides are in the same ratio. So here the corresponding sides are AB and A dash B dash. So let's take the ratio AB upon A dash B dash. It is 1 by 2. Similarly, the corresponding sides are BC and B dash C dash. The ratio will be 2 by 4, that is 1 by 2. So both the ratios are matching. Similarly, all the corresponding sides should be in the same ratio. That is 3 by 6, which is 1 by 2. 4 by 8, which is again 1 by 2, and 5 by 10, which is again 1 by 2. So basically in this figure, both the criteria are matching. That is the angle criteria, the corresponding angles are equal, and the second, the corresponding sides are in the same ratio. So we can say both the figures are similar to each other. Are you getting the concept? Here if we take the right hand side figure and try to scale in, that is reduce the size, its angle will not change, but its sides will change. The dimension or the length of the sides will change, but the angles will not change. So the corresponding angles are equal. You can increase the size or decrease the size, the angles will not change. Are you getting this concept? You increase the size or decrease the size of the polygons, the corresponding angles will not change. So this is the first criteria, the corresponding angles should be equal. The second, if you observe, as I am increasing the size of the right hand side polygon, the length of the sides are increasing, but they are increasing in certain ratio. If you apply the second criteria, here also it is matching. And all the ratios of corresponding sides are 1 by 3. So we can say both of these figures are similar to each other. Let's take the NCERT example. We are having two figures. Now a question to you. observe both the figures and try to implement our criteria. First criteria, the angle criteria. Second criteria, the sides criteria. And tell me whether both the figures are similar to each other or not. Pause the video, take your time and try to solve this question. Do not just skip this question. This will help you prepare mentally and build a strong foundation. So pause the video and come back once you are able to solve it. Just give it a try. You can be right or you can be wrong. Okay, pause it. So welcome back. Hope you have tried this experiment. These type of small experiment or small questions are very helpful to build a strong foundation. Believe me, I know that. So let's observe both the figure. First criteria, the corresponding angles should be equal. The corresponding angle to angle A is angle P, D to S and C to R and B to Q. So angle A is matching with angle P 105 degree, angle D to angle S 85 degree, angle C to R 70 degree and angle Q to B that is 100 degree. So we can say our first criteria is matching, that is all the angles are equal. Got it? But only the first criteria is not sufficient. We have to move to the second criteria, that is corresponding sides ratio. Let's see. Here let's find the corresponding sides AD to PS. So AD upon PS will be 2.1 upon 4.2, that is 1 by 2. Okay, let's move to next side, DC by SR, 2.4 upon 4.8, again 1 by 2. Let's move further, CB to RQ, 2.5 upon 5, again 1 by 2, that's good. AB upon PD, the corresponding sides, 1.5 upon 3, that is again 1 by 2. So we can say our both the criteria are matching, so both the figures are similar figures. Okay, very interesting question. Let's take one more example. This is slightly tricky. Let's take this example. You have to tell me, is both the figures are similar or not. Pause the video, take your time and solve it. Okay. So welcome back. Here we will try to find the similarity. First criteria, let's try to use the angle criteria. Here all the angles are 90. In the second figure also all the angles are 90. Basically the left hand side figure is a square and right hand side figure is a rectangle. Here all the angles are equal. Basically the corresponding angles are also equal. Angle A is equal to angle P, D is equal to S, C is equal to R and Q is equal to B. Basically the corresponding angles are equal. Our first criteria is matching. Very nice. Let's move to second criteria, the corresponding sides. AD is corresponding to PS, so the ratio of AD upon PS is 1:1, 3 upon 3, which is basically 1 by 1, that is 1:1. Let's move further. DC upon SR, 3 upon 3.5. No, it is not 1. So this ratio is not matching. The corresponding sides are not matching. So our second criteria has been filled out. Okay. You can try the other sides also, like the CB is to RS is 3 by 3, which is 1. And AB is to PQ is 3 upon 3.5, which is not 1. So basically our second criteria has failed out. Only first criteria is matching. So these two figures are not similar to each other. Both the criteria should match. Only one criteria will not solve the condition. So these two figures are not similar figures. So let's move to the last example. We are having two figures. Just you have to tell me whether both of these figures are similar to each other or not. Pause the video, take your time and come back with the answer. This time you should be fast. Okay. So welcome back. Here if you observe the corresponding angles, the first criteria, A to P, D to S, C to R and B to Q. So here the corresponding angles are not matching with each other. So our first criteria has been filled out. So these figures are not similar figures. Then also let's move to the second criteria, that is corresponding sides. So here AD is to PS is 2.1 upon 4.2, that is 1 by 2. DC upon SR is 2.1 upon 4.2, that is again 1.2. CB upon RQ is 2.1 upon 4.2, that is 1 by 2. And AB upon PQ is again 1 by 2. So basically the ratio of the corresponding sides are equal. That is second criteria is matching, but our first criteria is not matching. So these two figures are not similar figures. In the first example, we have seen both the criteria are matching, so both the figures are similar. In the second example, we have seen only the first criteria is matching, second is not matching, so that is not the similar figure. In the third example, this one, we have seen only the second criteria is matching, first criteria is not matching. So these figures are also not similar figure. So the final conclusion is that only if both the conditions are satisfying, then only we can say our figures are similar. Only if one condition is matching, second condition is not matching, then our figures are not similar. So that's the conclusion. So students, we have done with this lecture. Hope you have enjoyed the lecture created using the power of visualization, our unique way of teaching. And do not forget to download the formula and the concept list. The link is given in the description. And also this series or this lecture is part of the complete series on the triangle. The link to all other videos are given in the description. Also check it out. So thank you very much for being with CREATA Classes. Have a great day and meet you in the next lecture. Bye for now.